Here we are in the Waterford neighborhood, Lexington, Kentucky. The neighborhood is landmarked with two aesthetic ponds facing each other. Recently, one of the ponds, this one you're looking at, has experienced an increase in algal blooms, vegetation, sediment loading, and its fountain pump has been clogged, largely due to runoff from the fat mall and the development of the summit and the headwaters of the pond's contributing watershed. The neighborhood association and the people living there dream to see the pond's health restored. As this task was assigned to our team, we have framed possible solutions into two categories. Short-term solutions, which would partially alleviate the sediment load and the clogging pumps, and long-term solutions, which would fix the pumps and mitigate incoming sediment. As in many projects, design challenges and cost legal constraints have significantly impacted our design package.
I'll be talking about our general design solutions as well as their environmental impacts. We'll break this up into our short-term solutions and our long-term solutions. As far as the short-term solutions go, the first of these are the trash collector and pump screens. We were not able to implement these for testing due to issues with permitting with the Division of Water, but we do have that permit, and the materials for those will be left with Dr. Edwards. We did do calculations to determine that it would have no impact on upstream flooding or anything like that. Because of that, we believe that there would be no environmental impact as far as the aquatic vegetation or aquatic life in the pond, as well as any kind of issues with flooding upstream or problems with water backing up. Because we weren't able to implement those, we are leaving the permit application. The plans for designing and implementing those, as well as the materials that we purchased with Dr. Edwards in case the neighborhood association wants to pursue that option. Moving on to our other short-term solution, we found that there are devices called ultrasonic algae control. These devices emit ultrasonic waves that essentially rupture the vacuoles inside algae cells and cause the algae to die. Over time, and depending on the species, these devices can eliminate algae across ponds of various sizes, depending on the size of the emitter that you purchase. Some of the more expensive emitters are upwards of $3,000. Those emit pulses in 360 degrees, and some of the less expensive ones are around $1,500 to $2,000, and those emit 180 degree ultrasonic sound waves. Depending on the configurations that the neighborhood might want, they need to purchase two of the 180 degrees or one of the 360 degree emitters. But the main point to go along with those is that it was noted in the LFUCG Stormwater Incentive website that there were grants possible for the purchase of these starting in 2019. So if the neighborhood association was unsure about the long-term solution still, they could go ahead and implement the trash collector and implement an ultrasonic algae control device and possibly prolong the time until they would actually come to a point of having to dredge the pond. I would also like to touch back to the ultrasonic algae control device as far as its environmental impacts. The studies that have been done so far show that it has no real impact on aquatic vegetation or aquatic macroinvertebrates and fish. Now, Waterford Pond has been seeing some issues with aquatic vegetation as well. Algae control device will not work for that. There are other methods that do. That would just be for the algae control. It might help with the fountain pumps clogging. All in all, it seems to be relatively safe as far as environmental impacts. Now, moving on to our long-term solutions. The first of these is dredging. It's been talked about a lot by the neighborhood association. We used a complete topographic survey and bathymetric survey of the site to use that in conjunction with depth estimates that we received from the neighborhood association on the size of the pond in the past. And we were able to calculate the values for the dredging, how much material would need to be moved. Based on those, talking to a couple of contractors, doing some website research, we were able to determine kind of a cost estimate range for the dredging. We're looking at roughly $55,000 to $120,000 for that, depending on who's hired, the situations involved, where they would be able to place the excess material, different things like that, but you can expect it to be in that range. Most likely, we determined that it would be between $75,000 and $90,000 as a closer range. We think 55 and 120 are both pretty broad. As far as that goes, there would be no possibility of an incentive grant from LFUCG. As noted on their website, that dredging is not covered and not even applicable. So that would be completely out of the homeowners association pocket. Now the other long-term solution is to restore the stream system. It has a stream inflow and a stream outflow over the back weir. To restore it to a stream to kind of reduce the possibility of having to dredge in the future if there was no settling capacity that a pond has. We used a couple of different models to come up with a preliminary design. Based on that, as well as talks with contractors about pricing and our survey data, our topographic survey and bathymetric survey, we were able to come up with cut-fill data for that construction project and use that in conjunction with our stream models to gather a general cost estimate on what it would take to restore the stream. At this point, we're looking at roughly $200,000 to $300,000. That could change depending on the design of the stream. It could also change depending on how the riparian vegetation was planted, what other considerations the homeowners association wanted to put into the design. But that's a pretty good estimate. There is a possibility of stormwater incentive grants from LFUCG for these. There's a couple different options, the neighborhood grant, the municipal grant. It'd be more likely that the homeowners association would be able to receive a neighborhood grant, and those cap at $100,000. There's a lot that goes into these grant processes. There's no guarantee of that kind of money, but it is definitely a possibility, and that would reduce your costs substantially for going ahead with that project. Now back to the environmental considerations. The dredging really has relatively low impacts if it's done correctly, and the stream restoration has a positive impact. If it's designed for water quality, it can also be designed with the riparian vegetation to increase habitat, so it has a lot of positive environmental considerations.
The actual design of the trash collector and fountain screens are based on conversations with the fountain maintenance specialist. We were informed by the specialist that garbage and large clumps of algae are what were clogging up the fountain pumps. To fix this, we designed a trash collector boom that would go across the entrance of the pond in order to catch large debris before it could clog the pumps. Trash would hit the boom and be diverted to one side into a trash collection area where it would be cleaned out periodically. The boom was designed so that in high flow situations, it would float over the rod as shown and swing outward to be parallel with the flow. This would prevent the boom from breaking due to the force of the flow. We placed a smaller scale version of the boom in an experimental hydraulic flume, but were unable to gain any true data due to issues with the flume not creating enough current to actually push trash into a particular area. As mentioned earlier, because of the permitting issue, we were unfortunately unable to test the boom system at the pond. After looking at the fountain design schematics, it showed that there was very little filter to keep debris from clogging the pump intakes. To fix this problem, we had intentions of placing fencing around the pumps as shown in the drawings. We were unable to do this because the pumps had been removed for the winter and were placed back on the pond only a couple weeks before the end of the semester.
In our senior design project, I was responsible for a lot of the technological side of things, including some GIS work to delineate our watershed, modeling our watershed in HEC-HMS for permitting purposes, and using the Bankful model software to get a stream design figured out for our project. The problem we ran into with the trash collecting boom was the concern from LFUCG that the boom would cause upwater flooding. And to address this, we developed a hydrologic model in ArcGIS using HEC-GeoHMS. And this included different subbasins and reaches of the watershed, the drainage area, and parameters such as basin slope, river slope, and curve number. These were exported into HEC-HMS, and the 100-year 24-hour flow, which is the design flow for LFUCG floodplain purposes, was run through the model. The discharge of this output was used in HY8, which is a culvert modeling software, and this was used to get the height of flow coming out of the culvert that feeds the pond in the 100-year event, where the boom will be just downstream of the culvert. We modeled the boom as a floating sluice gate using this height and flow from the modeling softwares. With the sluice gate equations, we were able to calculate that there would be no upstream flooding, and so that would not be an issue, and this was included in our proposal to LFUCG. In the stream design process, we used the Bankful model that was created by Beaver Creek Hydrology here in Lexington, Kentucky. We input fluid parameters such as fluid density and mean annual temperature to get the fluid viscosity in Lexington, as well as bed material characters such as the median particle size and channel dimension parameters such as meander variance and wavelength frequency. Using this model, we were able to do as many runs as we liked until a stream model is output that we liked with the layout of the site at Waterford. This was then exported as a AutoCAD drawing file, which was able to be used in ArcGIS and AutoCAD. The AutoCAD, we had imported the data points that we collected in our full site survey and created a contour map, and we were able to create a surface out of those points and the exported file from the bankful model that represented our stream design at the correct elevation and calculate a cut fill volume of about 1,300 cubic yards in the stream design project. We were also able to use the DXF file and overlay it onto a DEM in ArcGIS and a aerial picture so you can see where the stream would be in relation to the current features at Waterford Pond.
In conclusion, we believe in the recommendations we've been able to come up with during the course of this consultation on Waterford Pond. We hope that the short-term solutions and long-term solutions will give the neighborhood association a lot to work with as far as deciding on whether or not to go ahead with a long-term solution or to start with short-terms for now. And we hope that the resources that we provided and the data that we provided will help them to move forward in this process, and we wish them the best. Thank you.